Space, the final frontier. It holds untold riches in the form of asteroids, celestial bodies teeming with valuable ores. These ores, remnants of the early solar system, contain a treasure trove of elements crucial for our technological advancement. Extracting these resources begins with liberating the ore from the asteroid. This is no simple feat, but the potential rewards are astronomical. Imagine a future where we are no longer bound by Earth's limited resources. Once we have liberated the ore, it is transported to processing facilities either in orbit or on a nearby celestial body like the Moon. These facilities act as cosmic refineries, transforming raw space ore into usable materials. The journey from asteroid to usable material is a complex one, involving a series of intricate processes designed to extract the most value from these celestial gifts. The first step in processing space ore is breaking it down into manageable pieces. This is where mechanical crushing comes in. Imagine giant crushers, similar to those used in terrestrial mining operations, but designed for the harsh conditions of space. These powerful machines pulverize the ore, reducing it to smaller and smaller particles. The goal is to achieve a specific particle size distribution, optimizing the efficiency of subsequent separation processes. This crushing process requires significant energy, often sourced from solar panels or nuclear reactors aboard the processing facility. As we venture further into the cosmos, developing efficient energy sources for these operations will be paramount. The crushed ore, now resembling a fine powder, is ready for the next stage, separating the valuable minerals from the waste material. With the ore crushed, the next step involves harnessing the power of magnetism. Many valuable metals, including iron, nickel, and cobalt, are naturally magnetic. This property allows us to separate them from the non-magnetic components of the ore. Magnetic separation utilizes powerful magnets to attract and separate these valuable metals. Imagine a conveyor belt carrying the crushed ore past a series of rotating magnetic drums. The magnetic particles cling to the drums, while the non-magnetic material continues along the conveyor belt. The separated magnetic materials are then collected for further processing. This process is highly efficient and environmentally friendly, requiring no harsh chemicals or excessive energy consumption. It's a testament to the elegance and effectiveness of harnessing natural forces for resource extraction. While magnetic separation proves effective for certain metals, other valuable elements require a different approach. This is where electrostatic separation comes in, utilizing the power of electrical charges to separate materials. This method involves imparting an electrical charge to the ore particles. Depending on their composition, different particles will acquire different charges. These charged particles are then passed through an electric field. As the particles move through the electric field, they are attracted to oppositely charged plates, effectively separating them based on their electrical properties. This process allows for the extraction of a wider range of valuable elements, including precious metals like gold and platinum. Electrostatic separation, like its magnetic counterpart, offers a clean and efficient method for separating valuable components from the ore. It's a testament to human ingenuity, adapting and innovating to overcome the challenges of space resource extraction.